As we move forward looking into this paper we've written, one thing to look at is operational efficiencies. This is often overlooked for many of you that have been working in data centers. You've probably been doing this silently, but you really haven't collectively put it all together. Everyone in the data center is performing it, but everybody's working in a silo. So basically, everybody's doing operational efficiencies, but they're in their own world. So what we want to do is try to get everyone together in data center and work as one team. So basically, all the decision making and everything that we're doing from this path forward is a community effort. So speaking of operational efficiencies, there are several steps that you'll need to take that we at Sandia have taken over the years, turning our legacy data center into a more modern data center. Some of the things you might want to do is take a look at your equipment to consolidate your computer equipment, look and see if you have ghost computers out there. So basically what this means is they're computers that are running, but they're actually not doing any work. There's other steps. If you have multiple data centers throughout your area, they're called satellite data centers. What you'd like to do is take a look at consolidating these systems, collectively move them into your main data center. And if you have a raised floor and you're looking at heading toward liquid cooling, you might want to take a look under your floor and see what's there. There's probably a huge amount of obstructions under the floor, fiber, cable trays that are probably not even used anymore. So you need to take a look and strategize how you'll best move forward with this. So what we did is we basically took a look at this system and we decided to move all of our systems above the floor with the exception of power. And so what we did is we basically built cable trays and started slowly transitioning our systems. And that goes right along with you look at your floor, you have a strategy for what you have on your floor. If you have cabinets and you have non-continuous rows, fix those rows up, get organized in how you deliver services for your power and cooling. Make sure that your front and back rows, you have flowing air, open spaces. You could use blanking panels within your equipment themselves, so you minimize the amount of airflow that you need to deliver to the services. You're often delivering too cold of air, too cold of water. You're wasting a lot of energy. What I did here at Sandia, I basically raised the water temperature and I raised the air temperature. So I did it very incrementally. So a few degrees every week. And by the time I went from when I took this data center over, it was somewhere around 59 F entering air. So you hang meat in there. So I went to 75 F in a matter of 6 months. In order to know where you're going, you need to know where you're at. So I would suggest doing something right now. And so you could take a look and get a really good idea of where you're at right now and at your system delivery on your air and your water side into your data center. And then as you move forward, then you have a trend. And so you could basically convert this to energy and to dollars and cents and to energy saved all the way back to the chill water plant. Okay, we're moving on to metrics. So once you start looking at your data center, when you're moving along from the air side to the liquid side, there's different metrics that you need to understand. So you get a sense of, you get your bearing straight, where you're at and where you need to be and where you want to go. So there's a lot of different metrics out there and everyone knows PUE. So I think PUE is a standard and that's a good metric to start out with and use. It's a real simplistic way to measure where you're at on your IT and how you're moving forward. And it gives you a sense of accomplishment as you're moving from air to liquid. And it shows that the energy that you're capturing is now going more to the IT side instead of the infrastructure side. So, and that's a good thing to show if you're trying to get funding or if you're trying to show, hey, this is exactly where I want to be, and in my future, then I could start looking into moving out further into the data center and showing the people that are in charge, your business people, how effective this can be. There are other measurements as well and the measurement family, and I reference a paper if you want to take a look and read through them and see the different metrics. One of them that I really like is the ITUE metric. So it's like PUE, but basically what it does, it takes the fan energy out of the IT and puts it on the mechanical side, the infrastructure side. So basically, all the little fans inside of your nodes and inside of your computers themselves would be on the infrastructure side. And so now you have a true idea of how much energy you're saving because you're taking those fans out basically when you're doing liquid cooling and you're putting a cold plate on there with pump energy to remove that heat. And all those little fans, although they don't seem like they do, they add up. So say for instance, if you have say a 20 kilowatt rack and you're trying to use air side cooling, probably around 2 kilowatts per rack is just fan energy. So if you take that on the other side now or you remove it when you're doing liquid cooling, you can see how effective you are. So the metric family is a good thing to reference. Don't forget to start out with that metric like PUE and see where you are now and then start taking measurements as you move forward. So what we're looking at here and referencing the paper again is that there's different people within the data center. You have your facilities people, you have your sysadmins, and then you have other independent contractors working within your data center. And collectively, when you're starting to transition from air to liquid, as you're combining all these your infrastructure stuff, then what you want to do is you basically want to do the same thing with your team itself. What you want to build like a team that's basically doing multiple functions within the data center, and you want to pull them all together. So, like at Sandia, we had IT folks, and then we had facilities infrastructure, and then we had some network people and some other people that were supporting in the data center. And we found this very ineffective in a way because everybody's pulled in different directions and they wanted to do different things within the data center. And it wasn't like a cohesive unit. So basically, it's a good time when you're starting to move toward liquid cooling and you're strategizing to put your data center in a better state. You might want to look at your key personnel and build them as a team as well. So they work together in the data center itself. So that's what I mean by building a cross-functional team. And instead of all these independent people going with their different ideas and what they want to do, you blend it all together slowly, and then you'll have a very cohesive and a very effective team. As we're moving toward liquid cooling, you have to look at how you're delivering the water or the air into your computers themselves and make sure you're not over provisioning the liquid or overcooling or actually undercooling as well, because then you're also working ineffective as well. So basically what you want to do is at least have a 10 degree to 12 degree delta. So coming in, warm your water up. You don't need to be that cold. And you'll find a happy medium. And so what you want to do is get it, listen, of course, go by the manufacturer and see what they have. I've always taken those with a grain of salt because sometimes they over provision. When you're looking at right sizing your system, there are simple formulas you could use, and one of them is three kilowatts on IT equipment equal 1 ton of cooling, and the 1 ton of cooling equals 400 CFM. So you could use that, and actually that's a good start. I mean, it's not exact, but it's close enough for right now. And then later on, you can fine tune it as you move forward. And also take a look at what IT equipment's coming down in the next 5 years, what the roadmap is. Are you going from 5 to 20 kilowatts and the next year? So then you need to build your infrastructure to support that and incrementally and move it up slowly.